So in Chapter 3, we learned that chemistry is concerned with two things, the structure of matter and the transformations from one form of matter to another. And then in Chapter 4, we discussed atoms and elements. In Chapter 5, we looked at the different types of ways that these atoms and elements might emit different types of radiation. In Chapter 6, we looked at ions and molecules and chemical bonding. In Chapter 3, we also explored the concept of a chemical change compared to a physical change. In this chapter, what we're going to do is we're going to specifically look at these chemical changes, also called chemical reactions, where one or more reactants are converted into one or more products. Chemical reactions occur all around us. They fuel and keep alive the cells of living tissue. They occur when we light a match, cook a dinner, start a car, or even stream a program on Netflix. Most of the world's manufacturing processes involve chemical reactions. They include petroleum refining and food processing, as well as the manufacture of drugs, plastics, synthetic fibers, fertilizers, explosives, and many other materials. In this video, we're going to discuss how to write and balance a chemical equation. Later on, we'll discuss types of chemical reactions, mass relationships in chemical reactions, and heat gains and losses in chemical reactions. So here in this picture, we can see evidence of a chemical reaction. The iron has reacted with oxygen to form iron oxide, and you can see this by the color change that has occurred or the rust that has formed on the exterior of the nails. We can describe chemical reactions using a chemical equation, where we use the chemical formulas for the reactants and products and an arrow to indicate the direction in which the reaction proceeds. It is also important to know the state of each reactant and product, that is, whether it is a gas, liquid, or solid. So what you can see here is we have our reactants here on the left side of the arrow. We can see carbon is in the solid state. Oxygen is in the gaseous state. You have the arrow indicating that the reaction proceeds to the right and forms carbon dioxide as a gaseous product. So when we write a chemical equation, an arrow separates reactants from the products. The reactants are written on the left side of the arrow and the products on the right side of the arrow. Multiple reactants or products are separated by a plus sign. The delta sign that we saw over the arrow indicates heat is used to start the reaction. Physical states of the compounds are denoted in parentheses following the compound. So we have solid, liquid, gas, and aqueous, which means something is dissolved in water. So table 7.3 summarizes the symbols that are used in chemical equations. A chemical equation is complete once it is balanced. What this means is that the number of atoms on the left side of the equation equals the number of atoms on the right side of the equation. This is because of the law of conservation of mass. We know that atoms are neither destroyed nor created in chemical reactions. They merely shift from one substance to another. Thus, all the atoms present at the start of the reaction on the left side must still be present at the end on the right side of the equation. So we can see here on the left, right, the chemical reaction is H2 gas plus O2 gas gives you water. Right. To balance the equation appropriately, there have to be 4 total hydrogen atoms on the left. There are 2 oxygen atoms, and then on the right we have our 4 hydrogen atoms again and our 2 oxygen atoms. All right, so here we're going to practice balancing a chemical equation. We have solid aluminum plus sulfur gives us Al2S3, or aluminum sulfide. So we can see that we have 1 aluminum and 1 sulfur on the left, and on the right we have 2 aluminums and 3 sulfurs. So what we need to do is we need to add a 2 in front of the Al and a 3 in front of the sulfur so that we can balance the number of atoms. So what we're going to do is we're going to use what's called a coefficient to balance an equation. Okay. So if we look here, this summarizes what I wrote previously, that the reaction was unbalanced as written. Right? And we're going to use a coefficient to balance each element. And then you can check the final equation to confirm it is balanced. And so once we add the 2 and the 3, we have a balanced chemical equation. So let's do this learning check. State the number of atoms of each element on the reactant side and the product side for each of the following balanced equations. So pause your video and write down your answer. So that you can see we have 4 phosphorus atoms on the reactant side and 4 phosphorus atoms on the product side. And we have 12 bromine atoms on the reactant side. It's 6 times 2. And then 12 atoms, 4 times 3 on the product side. For this reaction here, there are 2 aluminum atoms on the reactants and product side, 2 iron atoms on the reactants and product side, and 3 oxygen atoms on the reactants and product side. Now we have to balance the equation when we have solid Fe3O4 react with hydrogen gas to produce solid iron and water. So let's write the equation together. We're going to have Fe3O4 solid plus hydrogen gas, and it is going to give us solid iron and water. When you're balancing chemical equations, what you should do is balance all atoms other than oxygen and hydrogen first. Once those are balanced, you can balance the oxygens and the hydrogens. So we see that we have 3 irons on the left. So we're going to need 3 irons on the right. Now, let's look at the hydrogens. The hydrogens are balanced, 2 and 2, but our oxygens aren't. So we have 4 oxygens here on the left, but only 1 on the right. So let's put a 4 in front of that water. Now our hydrogens are not balanced. So in order to balance the hydrogens, because this now says that we have 8 hydrogens on the right, we're going to have to put a 4 in front of the H2. Now we have a balanced chemical equation. We have 3 irons on the left and 3 irons on the right. We have 4 oxygens on the left and 4 oxygens on the right, and we have 8 hydrogens on the left and 8 hydrogens on the right. So again, when you're balancing chemical equations, balance all atoms other than oxygen and hydrogen first. So this is just stepping you through the problem. Here is the equation as I wrote on the previous slide. Okay, it's showing you it is unbalanced. All right, so then we're going to use coefficients. And again, you can see we have our 1, 4, 3, 4 ratio. And when you do a final check, it's balanced. Now we're going to look at balancing with polyatomic ions. Remember, those were those ions that we looked at that were molecular compounds, right? So that they have covalent bonds, but the molecule has a charge. The key to balancing equations like this one is to realize that the polyatomic ion, phosphate, remains intact on both sides of the equation. So that you can see here in this table, when you are looking to see how to balance things and looking at the reactants and the product side, you're keeping that phosphate intact. So you're going to balance polyatomic ions as an intact unit. So on the left side, on the reactant side, we have 3 sodiums, 1 phosphate, 1 magnesium, and 2 chlorines. On the product side, we have 1 sodium, 2 phosphates, 3 magnesiums, and 1 chlorine. All right, so I see that I have 1 magnesium on the left on my reactant side and 3 magnesiums on the product side. I'm going to add a 3 in front of that magnesium chloride. And now what I'm going to do is I am going to see that my chlorines are unbalanced, so that I have 6 chlorines now on the reactant side and I have 1 chlorine on the product side. So I'm going to add a 6 in front of that sodium chloride. And then I see now I have 6 sodiums on the product side, so I need to put a 2 in front of this sodium phosphate. Now let's look at the phosphates. You can see that this 2 is distributed to the entire polyatomic. And now we have 2 phosphates on the product side. So we should be balanced. So let me just rewrite this so it's a little bit neater, so that we have 2 Na3 PO4, so 2 sodium phosphates, and that's aqueous, plus 3 magnesium chlorides, and again that's aqueous, and that's going to give us magnesium phosphate, which is a solid, plus 6 sodium chlorides, which remain aqueous. Okay. So if we write this down, we will see, okay, on the reactants and then products, that we have 6 sodiums and 6 sodiums. And then we have 2 phosphates and 2 phosphates. And then we have 3 magnesium 2 pluses and 3 magnesium 2 pluses, and finally we have 6 Cl minus on the left and 6 Cl minus on the right, so we are balanced. And so you can see that here nice and neat in table form. All right, so for this final learning check, you're going to balance and list the coefficients from the reactants to products. So pause your video and determine the correct coefficients. Remember, balance all the other atoms first before you deal with hydrogens and oxygens. All right, so let's go through this first one. Carbon is balanced on each side. So carbon, carbon. Our irons are not balanced, so I'm going to put a 2 in front of the iron on the product side. Let's look at my oxygens now. I have 3 oxygens on the left, and I only have 2 oxygens on the right. All right, so let's see. If I put a 2 in front of that iron oxide, I'm going to have to change my coefficient in front of the iron and make it a 4. All right, and then if I want to balance my oxygens, I need to put a 3 in front of the carbon dioxide, and then I can put a 3 in front of the carbon. So our answer choice is going to be choice 2. 2, 3, 4, 3. Let's look at the next one. All right, so our aluminums are not balanced, our irons are balanced, and our oxygens are not balanced. So let me start with the aluminum. So I'm going to put a 2 in front of the Al. All right, now I have to balance the oxygen. So I'm going to put a 3 in front of the iron oxide, and then I'm going to put a 3 in front of the iron, and now I should be balanced. So my coefficients are 2, 3, 3, 1. So that will be choice 1. Finally, let's look at the last one. This last one contains a polyatomic. It contains sulfate. So let's keep that polyatomic intact. All right, let me start with the aluminums. My aluminums are not balanced. I need to put a 2 in front of that Al on the reactant side. Okay. My sulfates are not balanced. I need to put a 3 in front of the hydrogen, the dihydrogen sulfate, or the sulfuric acid. Now my hydrogens are not balanced, so I need to put a 3 in front of that H2 gas. So now I'm balanced and my coefficients are 2, 3, 1, 3. So that is choice 2. So again, make sure you balance the individual elements before you balance the hydrogens and the oxygens, and make sure you keep the polyatomics intact. And so you can see here the answers laid out. So practice the assigned problems in balancing your chemical equations.